We're in Chapter 8, Lesson 3, Functions and Equations. Please turn with me to page 595. So, we learned that equations have to have an equal. Well, a function is an equation based on y equals some rule and x. So from this point on, we're going to use y and x in our relationships to write an equation. All right, let's keep going. Okay, so now we're going to define the vocabulary. First thing we have to do is talk about a linear function. Linear function, first four letters is line. So we know a linear function is going to make a line, and x is to the first power. X is to the first power. Everyday function. So miles per hour. Miles per hour would be a great example of a function. What do you notice about the function or the graph? It is a line. And last thing, math definition of a function. For every output y, there is exactly one input for x. Okay, in the real world, babysitting table shows the money Carly earns. So write a sentence that describes the relationship between the number of hours she sits in her earnings. So she makes $6 per hour. Does she earn the same amount? Yes. For every hour, she earns $6. So again, for every hour, she earns $6. So if I were to write that as a function, that would be 6x. Okay, turn the page. Write an equation to represent a function. You can use an equation to represent a function. The input is the independent variable, and that is your x. The output is your dependent variable, and that is your y. So whatever x you put in will determine what your y is. So dependent variable is your y, x is your independent variable. Dependent, independent. All right, let's look at example number 1. Okay, so write an equation to represent the function. And again, notice that our function is horizontal and then they make it vertical. When you make your function vertical, it's easier to see the coefficient and the variable. Alright, so in this case, the change in y, is your coefficient. So I know in this case, this is 9x. So y equals 9x. Now you want to know, is there any change for the constant? So for an input of 0, 0 times 9 is 0. So therefore there is no constant. So y equals 9x. Alright, your turn. And again, I like to write mine vertical so I see change in y. So 1, 2, 3, 4, 5, 16, 32, 48, 64, and 80. Look for your change. This is x, this is y. When you're done with that, check it out for 0, and that will tell you if you have a constant. So look for a coefficient, which is your change, and then see if you need to add anything. See you soon. Pause the video. Okay, so again, when I have it vertically, I can look at the change. The change in y is 16. So that is my coefficient, so I know it's 16x. When x is 0, y is 0, so I know there's no constant. So the equation is y equals 16x. So if we have a little linear function, we can graph a linear function. We do that by ordered pairs. So my ordered pair is input, comma, output, which is x, comma, y. And again, when we look at a graph, Your X is horizontal and your Y is vertical. Why? Because Y has a tail. Okay, turn the page. Okay, so now we're graphing the equations. We have Y equals 2X. So the first thing that you need to do is a table. When we do our tables, we normally set the values for X to be 0, 1, and 2. When you get to 7th, 8th grade, you're going to actually be setting it for -2, -1, 0, 1, and 2. But these graphs are only in the positive or first quadrant, so we're going to use 0, 1, and 2. So, we know that the equation is 2x. The input is x, so x, when x is equal to 0, 2 times 0 is 0. The order pair is 0, 0. When x is 1, 2 times 1 is 2. The order pair is 1, 2. When x is 2, 2 times 2 is 4. The order pair is 2, 4. And then you graph it. The x is the horizontal and the y is the vertical. So now it's your turn. Again, make a table. Up here, let's make this table. Actually, you need 3. X, and then your equation 0, 1, and 2. And down here, we'll have the other table. X, 3x plus 2, and your y. And again, we're going to do this 0, 1, and 2. So make your tables, find your order pair, and graph it on the graphs provided.
Pause the video!
Okay, so for x plus 1, we're going to solve for 0, 1, and 2. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. So our ordered pairs are 0, 1, 1, 2, and 2, 3. When I graph it, notice that it does not start at the origin. It does not start at 0, 0. All of these do not start at the origin, so do not try to make this line go down and fit here. Do not do that. That is wrong. Wherever it starts at 0 on the x, you find where it is on the y, and that's where you put your dot. Okay, the next one is 3x plus 2. When x is 0, 3 times 0 is 0, plus 2 is 2. 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6, plus 2 is 8. Notice on our graph that I cannot plot the position for number 2 because your y does not go up to 8. I can, however, plot 0, 2, and 1, 5. And again, connect my dots. Notice they do not start at the origin. Okay, let's keep going. Okay, so examples here. Mario constructed the graph shown which shows the height of the cactus after several years of growth. Make a function table for the input. So at this point, you're creating the table from the graph. So on the x, when x is 1, y is 42. When x is 2, y is 44. When x is 3, y is 46. So you compute the table, and then if you want to, we can turn around and get our equation, which is part 4. Write an equation for the graph. So the first thing we have to do is look at the spacing. The spacing is 2, and remember I said spacing is coefficient, so it's 2x. Then we have to set it equal to 0. So when this is 0, if that's 1, this is 2, I'm going to subtract 2, and that will start at 40. So that is my constant. So it's 2x plus 40. Wow, look at that. So again, it's 2x plus 40. So at 0, it was already 40, what is that, inches? 40 inches tall, and then started growing from there, which makes sense because you're not going to have a plant that starts out at nothing. Well, yeah, you would. You'd have a seed. Well, anyway, the point is it's 2x plus 40. Moving on. Now it's your turn. Make a table and write a function or an equation. Y equals.
Pause the video! Again.
Okay, so I graphed my ordered pairs. 1 is 20, 2 is 25, 3 is 30, 4 is 35. The spacing is 5, so it starts out as my coefficient being 5x. Then I get it up to 0 when magazines are at 0. The y is 15, that's my constant, so I have 5x plus 15. So my equation, that was my expression. Now, by setting it equal to y equals 5x plus 15. I have now written an equation. Okay, it's your turn. Please get the guided practice done and then come back.
Pause that video! Please. Again, pretty please.
Okay, so let's look at our answers. Number one, again, if you make your graph table vertical, it's easier to see than if you have a horizontal table. So my change in y is 4, so the equation starts with 4x. And then when 0 is 0, there is no constant, so it's y equals 4x. Number 2, x plus 3, I have to make a table, so when x is 0, y is 3, 1 is 4, 2 is 5. I find the points, I graph them. Note again, it does not start at the origin. For number 3, rain is 1 inch is 10 inches of snowfall. 2, 23, 34, 40, 0, 0. So again, y equals 10x. And then how do you use these? The ordered pairs are your x and y coordinates, so you always graph them. And notice on number 3 that we do have a linear equation, and it does go through the origin, which is 0, 0. Thank you for listening to the lesson.
All.
Bye.